So are there any questions on these guys? Either one of these? Okay. Stop me if you have any questions. Okay. The tangent you didn't have to do. We're going to work on tangent today.
I'm not kidding. Can we go over the cosine one?
Cosine always looks a little bit worse, but start with your pattern. Just work your pattern like this. And then don't worry about where it goes. So this is a phase shift of negative pi over 6. So you're moving 30 degrees pi over 6 to the left.
Oh, wait. Okay.
You're still a frequency of 1. So that means you have to go through 4 quadrants in 90 degrees. So the easiest way to start this is bring this out. So say this is pi over 6. And start this here at 1. And then yours are all incremented. Every 4 is your quadrant. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Just keep counting 4. So you need to complete 4 quadrants. So rather than get hung up on add 90, add 90, add 90, just count, 3. 1, 2, 3, 1, 2, 3. But then count your 90s that way. 1, 2, 3. So if you count here, and then you count 3, then you count, mine are just not incremented, 3, then you count 3. You'll see your max, your mins, your zeros.
Oh,
Every
yeah.
90 degrees.
Because yours goes past, past
This doesn't match up exactly to your.
Yeah.
But what I'm saying is, find your points.
Yeah, I got it.
Find your points, and it will make it look better. I like this website, this Math Bits, but I don't know why they did that.
Man, I'm really not good with the cosine ones.
The cosine just looks different because just write your pattern down. Don't even think about it. Just follow your pattern, just like you would your sine. What I always find the hardest is when the cosine is reflected and then kids get a little bit confused. So we took 3 cycles into pi. So every 120 degrees, and luckily you didn't have a phase shift here. So every 120 degrees. So here's your pieces. So when you started here, and you're a sine curve, and you're shifting up, and you're reflecting, and you're shifting up 1, start with your sine curve. Then multiply everything by a -1, and then add 1 to everything, and follow that pattern. Just go every 120 degrees, put a tick mark, so that you know where to stop. Okay? And no phase shifts there. 6 had a little bit of a phase shift, and a vertical shift down. Phase shift is your horizontal shift. It's just in trig, we just call it a phase shift. Because when you move your angles, it's a little bit different than your horizontal. So try to match up like your key points. Okay, now we get into the little tougher ones.
Oh,
All right.
there's so many cosines. I'm so bad at cosine. I don't know what it is. My brain doesn't work.
That's funny. That's probably because everything when it starts always looks like a sine curve. Even though it's the same wave, you just imagine it to be a sine curve.
I don't know what it is.
Probably that's natural where you start the curve, like right from your 0. You know, that's like the natural position.
Maybe.
Now, if you distribute this 2, here's the effect of this 2. It's really your frequency. If you did this, and then you did your phase shift, C over B, when you flip this over, the 2 is coming back out again. So that's probably why they left it like that. This is your B, your frequency, but your phase shift is pi over 3 to the right. And again, you're starting, and yours have tick marks in it, so you're starting at your pi over 3. And you're doing 2 in 2 pi. So your period is pi. So you have to go every 45 degrees. So this one's a little bit off in between. It's a little bit off your 30, right? It's like half, it comes between half of your 30s. If you have trouble, think in degrees, just, to help you out. So you're going to be a little bit off on this one. And then there's Ashley's favorite cosine. A pi over 90 shift. Excuse me. It has a pi over 2 shift, a 90-degree shift to the left. Amplitude is okay, but it's got a frequency change and it's got a shift down. Stop me if you have any questions. We can always take a look at the points.
Can we not have them this complicated on the test?
Your honors. Of course they're going to be this complicated.
What?
My regulars won't get one of these. My regulars will get like a number 7. And maybe the number 8. They'll get a number 8.
Number 8 was so complicated.
Yeah.
Huh? Number 8. So you're going to start with your cosine, right? And you have no amplitude change. You just have a shift down, too. So you're going to start by going down. You're going to say, what is this, -1, -2, -3, -2, -1. It's going to follow this pattern. Okay, that's the pattern it's going to follow. Where we start is the difference. So we've got to do 2 curves in 2 pi. So your period is pi. That means your quadrants have to be every pi over 4. Okay, and we have a phase shift. We're going to start, we're going to start to the left, -pi over 2. Now, if it helps you, expand this out and start it at -pi over 2. Here's -pi over 2.
But
Here's your 30 degrees.
if the
What?
2 is outside the parentheses, don't you have to distribute it so it's going to be 2 pi over 2?
2 pi.
It would just be pi, wouldn't it?
No, well, yeah, it will be pi, but then you're going to do pi divided by 2. You're going to, if you had this, it's going to work itself out. If you had this, right, and you crossed it out, it's still C over B. It will be pi over 2.
Oh, okay.
It will still work out the same way.
I get it.
It'll just wash it, like I did it here, it'll just wash itself out, which is why they put it out front, so you wouldn't have to deal with that part. Okay, so now you're going to start shifting this. You're going to start at -90, and you've got to go every 45 degrees, which is why these are off a little bit, and they're only coming out nicely on the 90s, not in between. Sorry, I got like a frog in my throat. So start at the 90. This is where you're starting. And this is your -1. And you're going down to -2 every 45 degrees. So this is 30, so 45 is in here somewhere. And so here you go. And you drop down, what is this, -2? And then you went to -3, another 45 degrees. You see it? You have to go every 45, so you have to put a little tick mark in between the 30s. Half of 30 is 15. And then you're going to do another 45 degrees to bring it up. So another negative in between here. There's your -2. The 90 part works nice because you're every 45 degrees. Then you're up there. See it? So take your tick marks and put little in between the 30s. That'll give you the 45. Mine weren't incremented by 30s, but yours are. So just change it. And easiest way, don't start smack in the middle anywhere. Bring it out like this. Bring it out and start it where it needs to start. I think that's the simplest way. I find it very hard to start in the middle. Go back and start it at the end. And then these guys. The sine one's not too bad. You shifted pi over 2. You shifted every 90 degrees. And you did 2 and 2 pi. And you could kind of count your 2. That one wasn't so bad. This one was a little bit involved. Here.
would still be the same since it's 2 pi. I don't understand.
Well, you got to pick 2. This is your frequency. I'm not sure I know what you're saying. So say, let's just expand this. Say this is your pi over 2. This is your negative pi. This is where you're going to start your sequence. So, but wait a minute. You're every pi over 2. You're every 90 degrees. There's your shift is pi over 2, not pi. That's why. Your shift is pi over 2. You looked at it. You forgot the 2. Your shift is 90 degrees, not pi. If it was pi, yeah, and that would have worked out. But your shift is C over B. So pi over 2. Your frequency is 2. Your shift is pi over 2, every 90. Good? Okay, and the last 2, I think they gave you these, right? They gave you these, or no, you had to do them. Okay, you had to do this. You had to come up with your equation first, and then you had to make your graph. God bless you. How's that looking? Oh, you got the cosine? There you go. And if it's a phase shift to the right, obviously don't make it any more difficult. Don't change the frequency. Just make it a plain old phase shift. Here's your word stretch out here. Translate up 1 unit. Just take your basic things, multiply them by 2, and then add 1. Does everybody find that to work? When you just take your regular things, I find that the easiest. And then when you're graphing, you're just kind of mindlessly following your pattern. Okay, let's go to the writing one. Okay, how's this one looking? Let me see if I can, I can't, oh, I can increase theirs up on the top. They're PDFs, they work a little differently for me then. Better? Okay, so what do the first 2 look like? Okay, you got a basic sine curve. All you changed here, check to see where did you start. And at your 90, there's your pattern. 0, 1, 0, negative 1, 0, 1. The only thing that changed was your amplitude. I got a basic cosine curve. Bring it down. Don't do any phase shifts in there unless you have to. Unless you see there is one or two with the phase shift in it. Basic cosine curve. And add 2 to them. So then you're starting here. You're above. Here's your shift right here. Here's your line. Here's your midline or your resting line. That's the best place to see your shift. And just an easier way to do this is just draw your new midline, and from that new midline, do your 1, your 0, your negative 1, your 0, your 1, because that's the only thing that changed. Whichever way you find easiest. Okay, we have a frequency, 3 frequencies here. So we've got 1, if you kind of count them. There's 1, there's 2, there's 3. There's your B. No other change. So that's why this is a 3. Okay. Alright, let's see what we have here. So the negative, I always find the negative reflection of cosine always looks the weirdest. It looks like you forgot something. Okay with these guys? This was a sine curve, took a shift to the right. To the left, sorry, to the left. Did anybody come up with another equation for this? Okay, Ashley, what'd you come up with?
Negative sine of x plus 1 might be wrong.
Jordan, what'd you come up with? Same thing. So let's see if this works. So here's your negative sign. So you started with, this is your reflection. So you were 0, 1, 0, negative 1, 0. There's more than one equation. So let's multiply it by a negative and add 1. And does it follow these? So you're fine. You don't have to do the phase shift. This one they did throw a phase shift in, but you can do a regular equation. And unless I tell you that you have to say phase shift, just find the easiest equation that you can. Here's another one. Then again, look for your two complete ones first. Here's 1. Here's 2. No matter where it is, just look for your two complete ones. That's your 2. You notice that it didn't start, well, it could have been a sign, I guess, right? Anybody do a sign?
Oh, it could have been more
Could have been a reflective sign with an amplitude, right? There's more than one equation you can come up with. Good? Okay, as long as you're comfortable with these. Because we have angles that don't have tangents to them. Why wouldn't an angle have a tangent? Undefined. Good. So here's our quadrants. Remember, these are your mins, your maxes. These are your curves. So we follow these for your curves. Now tangent says, y over x. So if and any time that my x is 0, I have to divide by 0, such as in this guy, such as in this guy. And we can't divide by 0. So there's where you're undefined. So there's where your asymptotes come in. So how could you define this for your domain? What could you say for your domain? Just say it to me in words first. What would your domain, if you're describing your tangent domain, what would you say? Can I use all real numbers here, all angles?
Excluding pi over 2
You would say excluding pi over 2
and 3 pi
and 3 pi over 2. And what else?
negatives.
And negatives. And that's all? Those are the only ones that I'll never use?
Well, I mean, you shift it and
We'll go around the circle again. Just do me another circle here. So, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 7 pi over 2. What's happening here? How would you describe this?
all of the odd pies over 2.
Oh, all of the odd pies over 2. Good. So we're going to start our domain to say real, except all of the odd pies over 2. So to say that, we're going to say except n pi over 2, where n is an odd integer. That's how we're going to define this, just like you just told me. You can't use the odd n pi over 2's. So our domain for tangent will be all real except, the little slash line means except, when n pi over 2, where n is an odd integer. What would my range be? Well, we didn't get to your range yet, but we'll do your range right now. So we walk through your unit circle. So your tangent is y over x. So what's 0 over 1? 0. And 0 over negative 1? 0. So here's a 0. Here's a 0. Where else would I have zeros? Negative pi. 2 pi.
all
Yeah, all the even pi's, right? They would all be my zeros. So now, Pick one in between, like a 45-degree angle. What's the tangent of 45 degrees? Okay, here's your 45-degree angle. 1, right? So what's the tangent of negative 45 degrees if I'm down here? Negative 1. So here's where my curves go. They all go like this. See my tangent curves? They all kind of go this way, because here's my 45, here's my negative. That's all you kind of need is just the 1 in there. So what's my range for tangent? Oh, can I have a tangent with greater than 1? What's the tangent of 30? In your calculator, tell me what the tangent of 30 is. What is that? No, just tangent. Tangent 30. 0.577. Okay, give me this. The tangent is 60. 1.732, right? So can we keep on going with it? Isn't tangent always greater? It's not always, but can it be greater than 1? Mm-hmm. So for our range, we are all real numbers. These curves will go on indefinitely. Both ways. But the key point is our asymptotes. So your asymptotes say you can't take a tangent at 90, at 270, or pi over 2, at 3 over pi over 2, at 5 pi over 2, all where they're odds. Okay? Basically, we don't do a lot with the tangent because there's really not a lot to do with your tangent. Okay? So now we're going to take a look at some of your reciprocals. I'm not sure how much you did with reciprocals last year. You didn't graph them? I can't believe that. What is cosecant the reciprocal of? Sine. And so, if I have the sine of 30, what is the cosecant of 30? 2 over 1, right? So cosecant can also be greater than 1. And we're going to see what happens here. So let's graph us a basic sine curve. In like a little dotted one. So let's take a look at these reciprocals. So at the 0 over 1. What is the reciprocal of 0 over 1? Because you told me just to turn it upside down, right? Just to take the reciprocal. So what is that? Undefined. So here we have an undefined part. We're a little undefined here. At the 0, we're undefined. Does everybody see why? Any of your zeros, and this is key, any of your zeros, as soon as you take the reciprocal, you can't divide by 0. 0 is the same as 0 over 1. So when we flip it over, we get 1 over 0. So at your zeros, make your asymptotes. Let's take a look at a couple more of these points. At the 1, when cosine is 1, what's the reciprocal of 1? 1. Okay, what's the reciprocal of negative 1? Negative 1. Okay, so let's take another one. Let's do sine of 30. So here's my 30. My sine of 30 is 1/2. What was its reciprocal? 2. So here it is over here at 2. And so over here, when this is 1/2, wouldn't this be at 2? We're taking reciprocal. okay? Same thing down here. I'm just going to keep with the 30s. So if we take the reciprocals of negative 1/2, what's the reciprocal of negative 1/2? Negative 2. And again, reciprocal of negative 1/2. See where your cosecants are going? Like this. All within those asymptote boundaries. They're reciprocals. So isn't sine and cosine always less than 1?
Yeah.
So if I take the reciprocal of something less than 1, which is a fraction, doesn't it give me a whole number? Not a whole number, but a number greater than 1? Mm-hmm. Makes sense? So this is how you graph your reciprocals. So let's take a look at your range first. My range says, my sine used to be from negative 1 to 1, but now I'm completely the opposite. So how would I set my range up?
You would say
I can't use anything in the middle now. I'm using all the extreme parts.
negative infinity to 1.
To
Or negative 1. I'm
negative
sorry.
1,
And then you would say, and then 1 to infinity.
good, and then 1 to infinity. Everybody see that? Uh-huh. Your original sine curve said you're in here. You're in here from negative 1 to 1. Well, your cosecant curve doesn't use anything in here. It uses everything outside of here. So now we're coming from down here as far as we can, stopping here at negative 1. Then we're jumping over the sine curve, starting here at 1 to infinity. Okay?
How do you list the domain?
Well, that's a good question. Describe the domain. What numbers can you not use right now? What angles can you not use? So we're real except, tell me what you can't use.
Even pi.
Okay, you're saying the 0, the pi, the 2 pi. You're saying
4 pi.
4 pi. Is it just even? What about negative pi? Can I use negative pi?
Yeah. No.
No. So what do you notice here? There's a 1. We're missing one in between, but you just didn't see it. So what are we saying? We're missing 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. We're missing any time it hits pi, right? All the pi's we're missing. So we're going to define our domain as all real except n pi, where n is any integer. And remember, it's not any number, it's any integer.
So you can't put in interval notation.
That one you can't because you can't use every angle. You'd have to do all these intervals forever and ever. So we just kind of make it a brief statement. Same thing as the tangent. The tangent you couldn't use pi over 2, the odd ones. So we said, okay, rather than keep listing them, we'll just say don't give me any odd ones. N pi over 2 where n is odd. This one we notice we have a pattern here. It's actually every pi, whether it's odd or even. So every integer, where n is any integer. Kind of makes a little sense? Okay? All right, now let's hit the secant. We're going to do that the same way. So your cosine curve starts with, again, 1, 0, negative 1, 0, 1. Just kind of make a little ghost of it. I find it much easier to graph off of a curve until you kind of get the hang of where all your domains are. I still graph off of these. Okay, so now, what gives us trouble here? What parts, what angles can we not take the reciprocals of when you look at this?
Odd.
The odd what? These guys, right? Pi over 2, 3 pi over 2. And right away Jordan said, oh, they're the odd ones. The odd pi over 2s, right? Because anytime I take a 0 and I take this reciprocal, it's undefined. So can you give me your domain right away?
All of the sides. Something n is maybe odd.
Uh-huh, and type just like your tangent, where n is an odd integer. And so since sine and cosine works the same in terms of range and all the angles, this is going to work the exact same way that your sine curve did. So even though this is my cosine curve, the reciprocals of 1s and negative 1s are still there. And then if I took a 1/2 in here, the cosine of 60 was 1/2, it would become 2. So again, here's your reciprocal curves. They stay inside those asymptotes. And they work like this. So since your sine and your cosine work the same, and your range for sine and cosine are both the same, your range for this guy is also negative infinity to negative 1, or 1 to infinity. And your domain is just like your tangent. Notice it's at the zeros, and you say it's pi over 2, it's 3 pi over 2. Whenever you get confused, say that to yourself. Say so simple. I have 1 pi over 2, I have 3 pi over 2, I have negative 1 pi over 2, negative 3 pi over 2. I'm noticing that they're odds. And that'll help you out. Now the cotangent is a little bit different. You don't like your cosine, I don't like the cotangent.
Oh boy.
This is a backwards approach. Okay, so here's my unit circle. And my cotangent is x over y. So which one is going to give me trouble when it's a 0? At where? At the 0? At the pi, right? Every time my y is a 0. So I can't take the asymptotes here. Shouldn't it work the exact opposite as tangent, since it's its cotangent, and since it's its reciprocal, right? Well, it does.
Oh,
it works
okay.
the opposite, and it would, right? Because you're just taking the reciprocal of those functions. So you notice now, every pi,
It's just the way you said it, it sounded like it wasn't going
that it wasn't going to. When we graph it, it just looks weird. So now, if I take 30, what's an easy one to take the tangent of? Well, 45. Yeah. If I take the tangent of 45, it's 1, right? So I'm still going to be at 1. I'm still going to be at a 1. But if I move over here into quadrant 2 and I take this cotangent, this is at negative 1. So it's the opposite way. It goes like this. It goes this way. It is the same concept, 45. Use your 45 to get your 1, your negative 1. But because you shifted this over, that's the difference. It's got the same exact range. It's still all real numbers in your range. But how can I define my domain? Real except what? What do you notice? Here's my asymptotes. Here, here, here.
real except n pi.
When n is what, Sarah? Any integer. Good. So you notice 2 of them are the same. And the tangent and the secant, and the cosecant, and the cotangent. You notice that those are the same. So at least they have a little bit of similarities here. Okay, I didn't get to the next example. Do the best you can. What my advice is, like on the next one, do your cosine code first, based on that information, and then do your secant. Okay? So try the homework.
I know, but we gotta go through the bio. On the Thursday, so which is like a Friday.